If you ping a IP address or domain name, for example, let me ping x.com and ping it only once, you can see it took only 42 milliseconds. But if I do the same thing, but using traceroute, just to measure the time, let me use time to run it. Start. Fast forward. Okay, you can see it took totally 35 seconds. Returns the complete routes, but for some of them, it's showing stars. And then for some of the hop, it shows multiple IP addresses. And for some of them, for example, this hop file, for some time, it's showing star. It's a very interesting, very slow process. So in this video, we will discuss how traceroute works, how it can even find the complete routes, where all these IP addresses come from, and why for some of them it cannot show the IP address. Okay, let's get started. On the screen, you'll see a terminal. I'm going to use this one to run the traceroute command. And then in the right side, you can see a Wireshark. Let me start capturing. Okay, started. It has nothing displayed yet because I already set the display filter to destination IP address equals to the x.com IP address. Okay, so now I'm ready to run the traceroute command. Let me run it. Okay, it's done. Stop capturing. Then let's try to understand what happened. Out of the 39 packets captured, the one in the beginning is the only one which is expected and easy to understand. It's from my local computer to the x.com, and by default traceroute use UDP, so there's nothing special. Move on. The second one, see what happened? It's from this .2.1 IP address to my local machine, and the message itself is TTL exceeded. This IP address .2.1 is my home router, the gateway for my home network to connect to internet. So apparently for the local machine to reach out to x.com, it need to first be routed by my home router, right? That's expected. But why my router will send a ICMP back to my local computer, and why the message says TTL exceeded? In fact, the second packet already reveals the secret of traceroute, how traceroute can even know the complete route. So if we go back to the first packet, and if we expand the IPv4 section, there's a value, it's called time to leave, or TTL for short. You can see the value set to 1. You may or may not know, an important behavior for a router to route a packet is it will decrease the TTL by 1. So let's think about it from this unified router perspective. Yes, it received the packet, need to be routed, right? It will decrease the packet's TTL by 1. But as we checked, the original packet from my local machine has the TTL value 1. And after being decreased by 1, the value will be 0. And 0 means something's wrong. The routing cannot be proceeded. The whole routing stopped at this second packet already. So basically what the second packet means, the router refused to proceed. The router notify the original sender, okay, your TTL exceeded. Then the routing stopped at the second packet, and the message type is ICMP, right? There's another thing I want to spell out. See the color of this packet? The second packet is black, and there are other black packets going forward. Why is that? Black means ICMP error. That's exactly what happened, because this second packet means the TTL is 0, right? That's how you can easily tell just by the color displayed in Wireshark. So now we are clear about the second packet. In fact, this finished the first hop just as it's displayed in the routing result. That's the first hop. Then move on. Now let's check the third packet. See, it's from the same local machine, the same destination, and if we check the IPv4 section, it's the same TTL value, which is 1. It's for the first hop. Then see the response is from the same unified router back to the original local machine saying TTL exceeded. Then if we check the third pair, it's the exact same situation from my local machine to the x.com, and then response from my local router to the original machine. So why is that? Why the same thing repeated 3 times? By default, traceroute will try the same thing. No matter whether it's successful or failure, it will try the same thing 3 times. So that's why for every single hop in the traceroute result, you can see 3 different durations or time because they are for the individual try. For example, for the first hop, you see the 3 times, right? Because traceroute tried 3 times. Then move on. Let's move to this packet, the 7th packet. So you can see it's from the same source to the same destination. But what's the difference this time? If you check the TTL value, it's 2. Why is that? Because traceroute just finished the first hop. Now it's moving on to the second hop. It need to find out what's the router beyond my local gateway, right? Then see what happened. It tried 3 times, but the difference compared to previous hop is it didn't receive the black ICMP reply from any router. Why is that? Because this particular router refused to reply, refused to send back the ICMP error message. That's exactly why traceroute couldn't determine the router name. That's why it displayed 3 stars. Each star means 1 failure. Because for this one, it didn't receive ICMP reply. For this one, the same. This one, the same. That's what the second hop really means, which is traceroute knows, yes, there is a router here, but there's no way for it to tell the router name. Why? Because the router didn't respond back with the ICMP packets. I hope it's clear about the second hop, right? Then move on to the third hop. So see, starting from this one, the local machine tried to reach out to x.com one more time, and then this time it got response back. It's from a real public internet IP address, and it returned back to the original machine saying the similar thing. The TTL exceeded. But this time, let's try to understand what happened. If we check the original UDP packet from my local machine from traceroute, if you check the TTL, it's 3. Let's use this diagram to try to explain what happened. For the first hop, the TTL was decreased from 3 to 2. In the second hop, the TTL was decreased from 2 to 1. When the third hop happened, when it reached out to this .250 router, the TTL was decreased to 0. That's why this router, the 250 router, sent back a response saying the TTL exceeded. And that's exactly how traceroute knows for the third hop was the router's IP address, right? And in the similar way, it tried the same thing 3 times. This is the first reply, second reply, third reply, right? So after this particular reply, the third hop already finished. Starting from this packet, it started the fourth hop, which is this one. For the fourth hop, just by checking the result, you can see something special. It listed 2 different routers. In internet, it's very common for some large-scale network, for the same source, same destination, there may be multiple routes, and the system will decide which exact route to take during runtime. So it may happen for the same source, same destination, you may see different routers for the same hop. Why for the same hop you see different routers? Remember we mentioned for the same hop, traceroute will try it 3 times, right? From the router perspective, the 3 times were 3 different routing. That's why you may end up with 3 different routes. But for our case, we have 2 different routes, and that's why from the time you can see for the first IP address, we only got 1 occurrence, but for the second IP address, we got 2 occurrences. That's how you read the fourth hop. We found 2 routers, and the second router was used twice out of our 3 tries. I hope it's clear for the fourth hop. Starting from this particular packet, we started the 5th hop. Similarly, the same local machine tried 3 times. You can tell from these 3 packets. But neither of them received ICMP reply from the router. That's why for the 5th hop, you see 3 stars. And someone may ask the question, why for the 5th hop, for these 3 packets, they are not in red color. Starting from this particular packet, we don't have red color packets anymore. So this is just the Wireshark default display setting, which means Wireshark doesn't think if you have a very low TTL value, that value makes sense. So if you check the very last red packet, what's the TTL value? It's 4, right? But starting from this non-red one, what's the TTL value? It's 5. For Wireshark, for value 5, Wireshark thinks it's a good enough value. That's why it's not shown in red color. But for 4, Wireshark still thinks it doesn't make sense. So it's just some display effect. Technically, the red color and the non-red color doesn't have significant meaning when it comes to traceroute. Okay, so we just talked about these 3 non-red packets. They didn't get ICMP replies. That's why for the 5th hop, we got 3 stars. I won't waste your time. For the 6th and the 7th hop, we had similar situation. Let's move on to the final hop, the hop 8. So this is the first try for hop 8 from my local machine to x.com, and the TTL value is 8. Then the first reply was from x.com. See the IP address? That's our final IP address for x.com. This time, the real x.com itself replied. That's so exciting, right? But let's see what's the message information. It's special. It's not the same as anything before it. It says destination unreachable, port unreachable. Why is that? If you try ping, let's say you directly ping x.com from your local machine, you will not see this type of ICMP response. Why is that? Finally, we can talk about the port used by traceroute. If you check any original UDP packet, for example this one, then you check the port information under UDP, you can see the destination port is 33456. So this destination port number is kind of hard-coded by traceroute. Of course, there's a small range. Normally, any router shouldn't have any service provided at this port, which means this port is an invalid port. No service should use this port. Because it's invalid port, when finally this packet reached this destination x.com, the IP address was correct, but the port number was invalid. That's why the destination couldn't provide the service. The destination x.com didn't know what to do. So it simply replied in ICMP telling my machine, I don't know what you are talking about. I don't have a port number 33456 which has a service. Rethink about your request. That's what this ICMP reply means. It sounds like a brutal reply. It sounds like a failure, right? But that's exactly what traceroute want to achieve, because it doesn't really want to do any reasonable request to the x.com. It only wants to know the route information. So as long as the packet reached to the x.com, as long as x.com replied, that's it. That's all the traceroute tool wants. So that's why it throws a invalid, unreasonable port number. Okay, so this explains the very last ICMP reply from x.com. After traceroute received this type of ICMP reply, which means it doesn't need to proceed. The hop 8 is already the last hop. Okay, so everything was successful, and then the traceroute command completed successfully. Okay, before ending this video, there's one last thing I want to explain about the durations or time you see in traceroute. You may wonder how the time is measured by traceroute. In Wireshark, you see the second column is time, right? If you go to the setting for Wireshark, you can set the time display format to many different ways. What I chose for this particular case is seconds since previous displayed packet. for example, let me use the third hop as example. So my local machine send a packet to x.com, right? And then at the fourth hop, the router replied with a ICMP packet. So see the time column, it says .0138886. This is the round trip time for my local machine to send out the UDP packet till it received the ICMP reply. So this time .0138886 was the one displayed here because this is the first try, right? If you check the second try, the time is .012379, which is this time. And for the third try, it's .010774, which is this time. You may ask why the number displayed in traceroute is slightly different than what we see in Wireshark. That's understandable because it's from different perspective, right? What you see in traceroute is the time measured by traceroute. What you see here in Wireshark is the packet received from the Wireshark perspective. Of course, they may be slightly different. Okay, thanks for watching.